Okay, hello students. I'm going to explain to you some of the things that I've seen during your completion and submission of your TYS work on moments. Okay, so now you can see that we are actually on the page where you have actually tried and completed. Okay, first question is to ask what is the drawn an arrow to show the position, okay, and the direction of the force that will leave the lead with minimum force. The keyword here is minimum effort or minimum force. Okay, so when we talk about minimum force or minimum effort, okay, we are actually trying to imply that your force needs to be far away. Far away from here, far away from the pivot, okay? So when you attempt this question, this must first come into your mind. Okay, so always identify where's the pivot first. So if you look at the diagram very carefully, the pivoting point is actually this part over here. Okay, where the metal rod actually touches the side of the tin polish. So in terms of force, force needs to be perpendicular or 90 degrees to the metal rod. Okay, so this is the first point that you need to make sure that is done. Okay, second thing is that the distance from the pivot should be as large as possible. And lastly, the force must be in contact with the rod. Okay, so only when you achieve these 3 points, then you actually obtain your 1 mark. What most of you actually did was to have the force is almost there. Most of you, your force is not 90 degrees a metal rod, but the distance, many of you actually achieve this point where it's as far away as possible from the pivot. But there's also a huge number of you who actually forgot that the force must be in contact with the rod. So let me draw it over here with a blue marker. Okay, the force needs to be over here, straight arrow please. Okay, and it should be 90 degrees to the metal rod. Okay, so let's indicate here as the force. So this is what we should see, okay, or this is what I should see, okay, when you are doing or submitting your work, okay, in order to get your 1 mark. Okay, next question. Okay, obtain the on the diagram mark with X, the position of center of gravity of the regular plane laminar as shown. Now for this question, right, it's actually something that I've gone through in class. Okay, but unfortunately, I'm not seeing the things that I need to see. Okay, so what you need to first do is actually take a ruler, okay, and make sure that your ruler, okay, is 90 degrees, okay, to the opposite side. Okay, and then from there, line it up with the vertex. Okay, let me line up with the vertex here. Okay, line up with the vertex. Then once you have done that, okay, draw a dotted line. Okay, with the, let me use a blue marker. And draw a dotted line. It's not doing what it needs to do. Okay, draw a dotted line. Okay, of course, you use a more thinner type of pen, okay, to the opposite side, okay, from the vertex to the opposite side. Okay, repeat the process for the two other vertices, okay, and once you do that, okay, then you'll be able to achieve the intersection. Okay, the intersection is the critical thing that we need to look out for. Okay, so let me line it up over here. Okay, the screen is not very sensitive now. I don't know why. Okay, so okay, this is also 90 degrees. This is 90 degrees. Okay, so once you have at least three of them, three lines, okay, they are perpendicular to the opposite side from at least three different vertices. Okay, you notice that they actually intersect at a point. Okay, and this is the part where it becomes crucial. Okay, because after you've done this, okay, the part here, this is the center of gravity. So I need to see this working shown, otherwise you will not get your point. Okay, so I'll mark it out with blue, the center of, oops, sorry, very thick. Okay, let me use something finer. I'll use a red marker instead. Okay, so you need to mark out very clearly. On top of that, you also need to leave the working, which is the dotted line, shown. Okay, otherwise you will not get your 2 marks. Okay, because the 2 marks really we need to see your working. Okay, which is draw the perpendicular dotted lines from the vertex to the opposite side. Okay, so this is how we actually obtain the CG. Okay, so must see. Okay, must see the working. Okay, and dotted line from vertex or vertex to opposite side. Okay, at least two of them, right? Okay, so after you have done, okay, label CG. Okay, now part B. You state one reason why the center of gravity of a car should be as low as possible. Many of you are able to tell me about the width, okay, of the car, okay, which is important, but you have not explain fully why it is important, okay, for the center of gravity to be as low as possible. Okay, you just left it as the weight of the car will help it to balance. Okay, but it's not clear enough how it helps to balance. Okay, and I've written down in many of your work actually that I'm looking for stability. Okay, this term or some mention of stability. Okay, so what is the reason that the center of gravity of a car should be as low as possible? Okay, you can explain, there are various ways that you can explain. Okay, one of the ways that we can explain is a low center of gravity increases the stability of the car making it harder to flip. Okay, so this is one possible answer. Okay, another possible answer that you can actually write is something of this way. A low center of gravity. Okay, I shall use the short form here. In the exam, please do not use short form. A low center of gravity will allow the weight of the car to stay within the base area for a larger area, makes it hard for the car to flip. Okay, for those who don't understand what I'm trying to tell you all here, okay, imagine this. Okay, if you have a car, okay, with the base area that is so large, so high, okay, when you flip it, okay, and the base area is still so high, when you flip it, the weight that is passing through, okay, from the CG, okay, the moment it pass by the pivot point, okay, it will cause the object to rotate, okay, this way on the clockwise direction. Okay, so if we can make this portion, okay, make this portion larger, okay, then or more like in this case, make the line of action, which is the weight, stay in the base area longer, okay, then it'll be better because it'll be harder to flip. Okay, so now imagine this scenario one, okay, this one flips easily. Okay, but if I allow you to imagine scenario two, where the CG is now much lower, okay, and same thing, I try to flip it, okay, same box, I try to flip it, you notice that when the CG is lower, it is harder for the line of action, which is the weight here, to leave the pivot point. Okay, to go past the pivot point, it will maintain within the base area. Okay, this allows the car to flip in the anti-clockwise direction, which will make it go back, okay, flip back into the correct space, right? Okay, so these are some things that you need to mention. Okay, the key word is definitely stability if you want to keep it short. Okay, or if you want to keep it longer, if you want to explain in more detail, then you need to mention about the base area. Okay, keep the force, the weights have to keep within the base area. Okay, so these are key things that you need to remember, right? Okay, last question. Okay, which of the two vase or vases, X or Y, is more stable? Okay, for this question, definitely the answer is X. Okay, definitely the answer is X. So if we analyze the two vase, okay, you notice that for X, the bottom part of the vase has more mass than the top part. This causes the center of gravity to probably be very low. Okay, this is the center of gravity there, right? Okay, on the other hand, the vase Y, you notice that the top half is wider. Okay, so this will make the center of gravity higher for the vase Y. Okay, so by having a low CG, okay, the vase X automatically will be more stable. Okay, so this ties in with the explanation in the previous question as well. Okay, so list the reasons, okay, for your answer. Many of you are able to tell me that X is more stable, but unfortunately, you are not able to really highlight the two properties I'm looking for. So what are the two properties that we are looking for? Okay, first one is talking about position of CG. Okay, when we explain stability, we need to mention about the position of CG, okay, as comparison to the other. Okay, second one is the base area. Okay, this one I'll explain in a little bit more. Maybe because many of you, instead of writing base area, you're telling me surface area, you're telling me other things, okay, which is actually not correct. So what is the answer that we are looking for? Okay, for this question, list two reasons for your choice. First choice is that the CG or center of gravity for vase X is lower than vase Y. Okay, you need to make that comparison. Without this comparison, it's hard for people to understand what you're trying to tell them, right? Okay, so now we talk about center of gravity. The second one would be about the base area, because if you notice the base area, Okay, for X is quite large compared to Y, which is quite small. Okay, so you need to mention this base area of vase X is larger than vase Y. Okay, so we need to use this word base area. Okay, and for this case, center of gravity, the position of center of gravity, these two are the key things that we're looking for. Okay, so before we end off this session, let me elaborate a little bit about base area, surface area, and contact area. These three areas are different, and we cannot use base area to explain. Sorry, we cannot use surface area and contact area to explain about the stability, because it has nothing to do with stability. Okay, so let's talk about the base area. Okay, let's use a chair as an example. Okay, so now I draw a simple chair. Okay, a side view of the chair. Okay, the legs are here, 4 legs. Okay, I hope you all can visualize what I'm drawing. And the 4 legs there. Okay, and then the chair. Okay, I know it's a very ugly drawing, but it's there. Okay, so the chair, the contact area. Okay, let's talk about contact area first. Contact area, okay, is actually the area that is in contact with the ground in this case. Okay, so if you look at the contact area, I'm going to highlight the contact area. 1, 2, 3, 4. The parts where the legs touch the floor is the contact area. And you notice that contact area is actually very small. Okay, but it does not explain why the chair is stable. Because if I compare it to a similar chair, okay, a similar chair, okay, which the bottom, a similar chair, but the bottom is not so spread out as this particular one. Okay, you notice that, right, if let's say the chair, all the legs are bent in this way, and then I ask you to balance the chair like this, do you think this chair is going to be more stable or same stability as the other one? Yeah, I don't think so, because in this case, my 4 legs, they are bent together. The contact area is the same 4 contact area that is in contact with the ground. Okay, and this one is actually not stable. Okay, so stability has nothing to do with contact area. Okay, now let's talk about surface area. Okay, so for surface area, I'm going to highlight in yellow. Okay, surface area. Surface area refers to the area of the surface of an object. Okay, so if you look at the surface of an object, which I'm going to highlight in yellow, the surface of this chair is actually everything. Okay, the 4 legs, the top of the chair, the bottom of the chair. Does this have anything to do with stability? Obviously, the answer is no, because a larger surface area doesn't guarantee a more stable object. Okay, so I give you another analogy. Okay, you as a person, okay, when you are going to fall down, okay, on the floor, okay, is your skin, the whole body of your the skin on the whole of your body, does it have anything to do with stability of you when you're about to fall down on the floor? Answer is no, because what I'm trying to say here is even the skin on your hand, the skin on your head, the skin of your face, it has nothing to do with stability. And this is surface area of a body. Okay, the surface area of a body is basically the skin. Okay, the surface of the skin. Okay, on the other hand, when you are about to fall, what your legs are trying to do is actually try to spread out further. When you spread out further, you are trying to create a bigger surface area, a bigger base area, okay, that is in contact with the ground. Okay, which brings me to the last point, base area. Okay, base area, I'm going to use green color to annotate so that it's easier for you to see. So where is the base area of the first chair over here? The base area of the first chair is actually this area that is being occupied, the space that is being occupied by the chair. Okay, so the base area is basically the space occupied by chair. It has or in by the legs, sorry, the legs of the chair. Okay, so it has it is actually a rectangle underneath the chair there. Okay, so it has nothing to do with the surface area. It has nothing to do with the contact area, okay, of the object. Okay, so with this, I'll end my explanation. If you need further clarity, please go and read up your textbook, okay, or the revision booklet that comes with your TYS. Okay, so hopefully it will help clear up some doubts that you have. And last but not least, okay, please remember to continue to submit your work on time, okay, if is assigned on MS Teams, right? Okay, so everyone stay safe, okay, and stay healthy. Okay, with this, thank you everyone. I hope to see you all in term 3.